For decades, water quality could only be measured in laboratories. Samples were collected, transported, analyzed hours or days later. But water quality changes continuously, and by the time the result arrived, the water had already been consumed. Today, sensor technology is moving analysis from the lab to the home, from delayed results to instant detection. Modern smart sensors do not measure a single parameter, they operate as multi-parameter platforms. In real time, they monitor pH, electrical conductivity, temperature, turbidity, oxidation reduction potential, residual disinfectant levels. Together, these values create a continuous fingerprint of water quality, not a single number, but a dynamic profile. Electrochemical sensors measure chemical substances through controlled reactions at an electrode surface. They are used for detecting free chlorine, dissolved oxygen nitrate heavy metals in advanced systems. These sensors are compact, energy efficient, and fast. This makes them ideal for continuous home monitoring. Instead of waiting for a lab test, the system knows immediately when disinfectant levels drop below safe thresholds. Optical sensors analyze how water interacts with light. By measuring absorption and scattering, they detect turbidity color changes, organic matter presence. UV absorbance sensors can identify variations in dissolved organic compounds, often linked to taste, odor, or contamination events. These technologies require no chemical reagents. They operate continuously and autonomously. Direct real-time detection of pathogens in homes is still a developing field. But biosensors can detect indicators associated with microbial growth. Changes in ATP levels, enzymatic activity, biofilm formation potential. These early signals warn the system before microbial contamination becomes a health risk. This transforms water safety from reactive testing to preventive monitoring. The location of a sensor determines the meaning of its data. At the main inlet, it measures incoming network quality. After a treatment unit, it verifies performance. At the tap, it reflects the actual water being consumed. Strategic placement creates a complete picture of water quality inside the building. Sensor data must be translated into simple information. Users do not need raw chemical values. They need clear answers. Safe to drink, flush the tap, replace the filter, check the system. This requires intelligent interpretation and intuitive interfaces. Technology becomes useful only when it becomes understandable. Miniaturization is transforming analytical chemistry. Microfluidic systems can perform complex tests automatically using tiny volumes of water and reagent. In the future, home monitoring devices will detect specific contaminants, emerging pollutants, trace level chemical changes. The boundary between laboratory and household will disappear. The safest water is the water that is continuously understood.